Hello students, in today's lecture in linear algebra we'll see explanation to consistency of a system of linear equations and condition for consistency and types of solutions. So details of what is consistency and conditions and different types of solution we'll see now. Hello students, in today's lecture we'll see consistency of a system of linear equations. So here we'll see what is this consistency of a system of linear equation. Consider a system of m linear equation in n unknowns, which are as follows. Now here it is given as a11 x1 plus a12 x2 plus so on plus a1n xn is equal to b1. Second equation is a21 x1 plus a22 x2 plus so on plus a2n xn is equal to bn. So on am1 x1 plus am2 x2 plus so on plus amn xn is equal to bm. So these are nothing but a system of equations. Okay, so these are the system of equations having what here m linear equations in n unknowns. So here I can say that a11 a12 a1n, so similarly a21 a22 a2n and all, and b1 b2 so on bm, all are what here constants. Then the set of linear equation is said to be consistent. Okay, it is going to call as consistent if it possesses a solution. Okay, means this all x1 x2 x3 so on xn, all whatever is there, variables are there, if we get a value of those x1 x2 so on xn, then we call such kind of equation as what here consistent equation. So therefore the set of linear equation is said to be consistent if it possesses a solution. Otherwise the system of equation is said to be inconsistent. Okay, so we have two cases here. So the given equations what we have, if that variable having what here values, then I can say that system of equation is going to call as consistent. Then otherwise it is called as what, inconsistent. Next, the above system of equation can be written in the matrix form. Means this equation we can write in the matrix form as this. A means coefficient of x1 is a11, coefficient of x2 is a12, so on, coefficient of xn is a1n. So this is the first row elements, second row elements, so on, mth row element. So we'll write that in the form of equation now, matrix now. Just see, the above equation can be written as what here, matrix a11 a12 so on a1n. Second row element is what here, a21 a22 so on a2n. So similarly so on, what we have here, last equation what we have in this, the same will take, that is am1 am2 so on amn. So which is nothing but it will be a m1 a m2 so on a mn into, it will be variables are x1 x2 so on xn, which is nothing but that is constants, that is b1 b2 so on bm. So this is of the form, this is a matrix A into variable is equal to the constant. So I can say that, where here I will consider this one as what here, this completely I will consider as matrix A. This completely what column matrix we have, x1 x2, so xn I will consider capital X. This equal to sign equal to what here, this is nothing but what here, B. This matrix A, matrix X, matrix B. So therefore where A is the matrix of order m cross n, okay, then X is a matrix of order n cross 1, and hence the product is denoted by what here, B, and which is having a order what here, m cross 1. So here what happens, according to the situation, so here x1 x2 x3 so on are equal to 0. So the solution of the homogeneous system of equation is called trivial solution. If this b1 b2 b3 so on bm, if it is becomes 0, then we call it is trivial solution. And if suppose these values are getting what here, the values like 1 2 3 so on n, then we call it is what here, non-trivial solution. So the system of equation Ax is equal to B may or may not possess a solution. Means it may get the solution, it may not be get a solution. If the system possesses a solution, it may or may not be only a solution. Fine. The concept of the rank of matrix help us to conclude what here, first, whether the system is consistent or not. Means here I can say that again rank of a matrix plays an important role. Whether the system is consistent or no, we can judge by using what here, rank of the matrix. Then second point you can remember here, whether the system possesses unique solution or many solution. So these are the 2 points we'll see here. So which is going to consider what here, in the form of a condition for necessary and means a condition for consistency and types of the solutions we'll see in our next part here. So let's see what is that condition. Means here whatever matrix we have, so we'll check, we'll find the rank, and based on this rank again it can defined as whether the system is consistent or no. And if it is consistent, then which kind of solutions we have. We have almost 3 kinds of solution, especially 2 kinds of solution, that is unique solution and infinite solution. So when it is possible unique solution and when it is possible infinite solution, we'll see in the form of what here, condition for consistency and types of the solution. Let's see that one. Condition for consistency and types of solution. Consider a system of m equations in n unknowns represented in the matrix form Ax is equal to B. So I have taken here, so what is matrix A? That is A11, A12 so on A1n, A21, A22 so on A2n, then so on AM1, AM2 so on AMN. And where the matrix capital X is nothing but x1, x2 so on xn, and matrix B is nothing but b1, b2, b3 so on bm. Okay, so once we got these cases, so we'll check whether these conditions satisfy for consistent or not. So here I can say that what matrix A we have. So A is called the coefficient matrix. So matrix A is called what here? Coefficient matrix. Why it is coefficient? So if you see the equations, so in that equations means a system of equations we have seen. So a coefficient of x1 is a11, coefficient of x2 is a12, so on. So that's why, so it is nothing but coefficients of what here, x1, x2, x3 so on xn. So therefore it is going to called as what here, a coefficient matrix. The matrix formed by the matrix formed by appending to A matrix A an extra column extra column, very important this one, extra column consisting of the element of B is called the very important called augmented matrix, AUGMENTED augmented matrix, and denoted by matrix A dot B. Here you can see augmented matrix. So therefore I can say that we know that what is matrix A and matrix B. So how to write here? So it is nothing but augmented matrix AB is written as matrix A element, that is A11, A12, so on A1n. Similarly, second row A21, A22, so on A2n, so on AM1, AM2, so on AMN. Next, instead of writing equal to, matrix B elements are what here? B1. Second row it is B2, so on. For the last row it is BM. Okay, so here also it is BM. Okay, it is BM. So this what situation we are seeing here? So it is called as what here? Augmented matrix. So it is nothing but what here? One of the column we are extra column we are adding in what here? Matrix A, and if you add that column which having the elements of matrix B is nothing but what here? Augmented matrix. So here this is one of the very important. So using this matrix only we need to find the rank of the matrix, and then we can check whether it is consistent or inconsistent. If it is consistent, so which kind of solution it having? So if it is consistent, we have two kinds of solution. One is unique solution and one is what here? Infinite many solution. So if it is inconsistent, then there is a no solution only. So we'll see that if it is consistent, what happens, and if it is not consistent, that is inconsistent, what happens? We'll see now. So I can say that the system of equations represented by the matrix equation, that is Ax is equal to B is consistent. Just see here, if is consistent if rank of matrix A is equal to rank of augmented matrix. Means both rank should be same. If both the ranks are same, means matrix A and augmented matrix A, we need to find the rank using Equivalence form. If the rank of the matrix A is same as the rank of augmented matrix A B, then we can say that the given system of equations are what here? Consistent. Now just see here, suppose I will say that rank A is equal to rank of augmented matrix AB is equal to some answer R. Means we got the answer, rank of matrix A is R and rank of augmented matrix also what here? R. Then we can say that it is consistent. Then if it is consistent, then the condition for two types of solution, okay, so two types of solutions are as follows. So we'll see that one, which are the two types. So first one is unique solution. I told you already, it is unique solution. If it is consistent, unique solution is also possible. So unique solution. So when it is going to called as unique solution, we'll see simultaneously. So if it is consistent, it may be unique solution. If it is unique solution, what is the condition here? It's supposed unique means rank of A should equal to rank of augmented matrix AB is equal to R is equal to N. So here I can say that N being the number of unknowns. Number of unknowns means that equation is made up of what here? Either x1, x2, x3, so on, xn, or I can say that system of equations is made of what here? X, y, z, or x1, x2, x3, or y1, y2, y3. Means how many variables they have used to make that equation. That is nothing but value of n. So I can say that, so that value and the rank value, if it is same, then we can say that it has unique solution. And second kind of solution, if it is consistent, is that is infinite solution. Infinite solutions. So when it is infinite solution, we'll see here rank of matrix A is equal to rank of augmented matrix AB is equal to, if it is suppose R, and rank, if both the rank, if it is same and if it is less than n, then we can say that it is infinite many solution. See, both the conditions are very important when it is unique solution. So rank of A and rank of augmented matrix AB, if which is R, and here the number of unknowns, that is that equation made up of what here? X, Y, Z, suppose. Then x, y, z means three variables. So R is 3 and N is 3 means we can say it is unique solution. If R is 3 but N is 2, or R is 4 and if it is N is 3, at that time it is infinite many solution. If it is not applying the condition, then we can say that it is what here? Not a solution only. It has inconsistent, means it may be what here? Inconsistent. So next I want to tell you here one more important point as, so when it is inconsistent, that is very important. If, very important, concentrate, if rank of A is not equal to rank of augmented matrix, okay, if it is not same both the ranks, then the system of equation is inconsistent. Then the system is inconsistent. So remember, if it is same, then we have two cases, that is either unique solution, infinite solution. So when it is unique solution, the rank value and the number of variables will be same, then it is unique. If it is rank is less than what here, rank value, that is rank is less than, if it is number of variables then it is infinite, and if the both the ranks are not same then it is what here, inconsistent. So first the questions will be based on what here, test for consistency. So if it is consistent we have two cases, if it is ranks are not same then it is inconsistent, we have to stop the problem. So we'll see more detail by using what here, one of the simple example based on this consistency. So in our next lecture we'll see the problems based on consistent or inconsistent. So to get more videos regarding this module, so you have to like the channel, you have to subscribe and give more comments for your upcoming videos.